Hello and welcome to the Open Source Silicon Stream number 14. And we've got a lot to catch up on this time because the last 3 weeks have been cancelled for some reason or another. I think I got ill last week. Let me know where you're listening from and whether the audio is okay. If you've got anything that you want to be covered today, you can drop a note on that as well. But yeah, we've got plenty to catch up on, like nearly 3 weeks of news. So who's tuning in this week? Can't actually see unless you leave a comment. I think I can get it from here. Oh, hi, Thomas. Hi, Rohan. Thanks for letting me know. Denmark. Rohan's from India. Leo Mosa, tuning in from Austria, do I recall? Good to have you here. So let me move into the news section. Okay, I'm going to share my screen as well here. There we go. News. So, yes, 14th, number 14, 2nd of June. So first thing is SpaceX is going well. I think we've got 12 designs now added and ready to go when that launches in early 2026. But everything needs to get sent over to Tibor, ready for integration into the satellite system. But we did get an update that we've got a bit more time. So now the new deadline is the 20th of June. Let me just double check that. '20th of June. Yeah. So join the SpaceX channel if you want to get involved with that. That's where we can answer all your questions. Jörn's here. Hi, Jörn. Good to have you here. Denmark. Jörn, have you just had the your camping festival? What's it called? Bornhack? Or is that coming up soon? Also, FPGA Geek says hi from Florida. Hi, and welcome to the stream, FPGA Geek. Also, Pat has done a couple of videos recently. Psychogenic basic. Well, I was expecting to get that on the first hit. That is odd. There we go. So, yeah, I think Pat's done 2 videos now. This one, can you design a space circuit in weeks? Watch me try. And from PCB to space, assembly testing and coding for low Earth orbit. I just dropped the latest one in the comments. Oops, I think I dropped the entire doc there, which is fine as well as public document. And that was the one I wanted to show though. And Jörn and Thomas both say Born Hack is July 16th. If you've not been to Born Hack, then definitely check it out. It's a lot of fun, I've heard. I've still not been, but I'd love to go one day. Okay, so that's SpaceX stuff. Okay, so then on current shuttles, so always the place to go for shuttles is Tiny Tape Out website on the chips page. So these are the upcoming ones. Well, actually, the one that is open right now is IHP 25B, closing in 90 days. That's the one that has some export limitations on it. And then we've got 2 coming up with Skywater via Chip Foundry. And then another one with IHP in first quarter 2026. And I believe that this will be the first one with IHP where we'll be buying the chips and we'll be able to send them wherever we want to. Anybody here listen to the Hackaday podcast? There must be a couple of you. Thomas, you probably do, don't you? Anyway, it's one of my regulars. I listen to podcasts when I'm clearing the kitchen, doing the housework. And they were given a tip recently of this video from Hunter Adams, who's a lecturer. I can't actually remember where he's a lecturer. Teaches a engineering course, and one of the topics is building with microcontrollers. And he did a not very technical talk, more about his interest and his love for engineering and why he thinks that microcontrollers is a good pathway for exploring lots of different fields. One of the things he mentioned is that they're quite limited, and limitations can result in some great creativity, which I'm also a big believer of. And I think that's one of the interesting things about Tiny Tape Out. Anyway, I listened to it on Sunday, and I recommend you having a listen as well. I think it's a really good talk, so I just wanted to share it wider. So drop a link in the comments there. Big news is Ray's Z80 is working. Ray made this little video of the Z80 waking up and counting up. And this is going to be, after we finish the news, this is what I'm going to spend the rest of the time focusing on, looking at the Z80 and trying to run the test programs and maybe even write a test program. So if anyone in the audience is a Z80 fan and wants to write a little bit of assembly, we can try and run it. So that's just a heads up to dig up your Z80 assembly reference manuals or some older programs you might have lying around. We'll get to that. So that is excellent news. That was covered quite widely in the media. Got us some good coverage last year. I think it was covered by Tom's Hardware, Hackster, The Register, Hackaday, EE News. Pretty good for us as a super niche project. So good to see that out there, and good to have like an alternative for the iconic Z80 now discontinued. I would love also to find out more about exactly why that got discontinued. The theory is that the fab had to shut the line for some reason, but I don't know if that's true. I'd love to speak to somebody who knows more about that. Sylvain says, oops, I'm a little late. Hi, Sylvain. Thanks for joining. We don't mind if you're late. You can always rewind time. What's next? Okay, so 0 to ASIC course. Probably a lot of you know me through my 0 to ASIC course. And if you don't know, then that's kind of one of the ways I really got my foundation in the open source ASIC stuff, was doing my first tape outs, seeing that there was a demand for other people wanting a step-by-step guide to doing their own tape outs, which spawned the Zero to ASIC course, and that's kind of allowed me to focus full time on open source EDA and ASICs. And one of the things that's difficult about running a course is keeping everything up to date and making sure that the install instructions work and that the examples work and the labs work, and things are constantly going out of date. Sam is here. Hi, Sam Elcott. Welcome. And I've been testing Harold's OSIC Docker, IIC OSIC tools. And this is a very easy to use, everything in one place Docker image that works on all the different operating systems and is fairly easy to get set up and working. Harold is a Mac user, so I know it works with a Mac. That's been one of the things I've been finding it difficult to support Mac users. So I've been testing it out, and as I've, I'm not a massive Docker fan, but it does have its place, I think. So I've been learning a bit more about Docker, and that has then, I opened a bunch of pull requests and things that were going wrong that I couldn't get to work with my course, and Harold and the other person he has who's maintaining this repository were very responsive, which is always a great sign. Helped me to close all those issues. So I was able to get all my course labs tested, regression tested with the Docker, which I thought that's like the first step to make sure whether this is something I want to move over to. And I created a composite action. So GitHub Actions are very, very useful. If you don't know them, I would definitely recommend spending like half an hour looking into them just so that you know that it's there if you want to use it in the future. But basically, you have some YAML, you commit it to the right place in the repository, and then every time you commit, it will spin up a virtual machine and run some commands that can do pretty much whatever. And I made a composite action, which is basically is a function. So you've got to provide it with these four things: a repository, a branch, the command to run, and some artifact file to store. And then it grabs Harold's Docker and runs the command and then stores any artifact. And then for all of the Zero to ASIC course, digital course projects, let's take a look at the Magic MOSFET. That's the first one. I added a regression test, which uses that composite and then tells it, this is the repo, that's the branch, this is the command to run, and at the end of it, there should be this file which you should save an artifact. And then this runs when I push or when I press the button or on the first of the month. And Harold's now added this to the Docker, so it has a built-in set of pretty basic regression tests. But I like the model, and I really like knowing that all the course material is going to be working and is always up to date and works with that Docker, and is reproducible. And if something goes wrong, I'll know when it goes wrong. So I think that's quite, if you're thinking of running a course, there's nothing more annoying than finding that material that you're searching for, and then you run it and something goes wrong, and then you have to search like what's gone wrong. And if you're running a course that people are paying for, it's important for people to have a good user experience. So I've been using GitHub Actions to test the install instructions for a couple of years now, but now I'm going to also be running regressions on all the projects. This is for the digital course, and I'll be doing the same thing for the analog course shortly. So I just wanted to share that here as a useful technique. Okay, next item on the news list is we did a very, very tiny tape out, much smaller than usual. Where's the chip repo? Yeah, actually I wanted this one. So only 32 different tiles. It was a test on IHP. We had access to the fast transistors. It was like a free experimental tape out. We're not expecting to like make these up and send them out to people. We might do that with a few. And these designs were all submitted by people that have been involved in the project and submitted things before. Although having said that, it was the first, because I've been doing this silicon art project with Sabine, who was on the stream 3 weeks ago, I think. And she did this design that is going to play next on this little reel here. This one, that's her first Verilog chip design, and we submitted that on as well because she missed the previous IHP one. Sam says, does that Docker have all the analog tools? Yes, it's got all the tools basically. One thing that I just found out is that it is all the latest versions of the tools. So it's a bit like the OSS CAD suite from Yosis HQ. So you're always up to date, which is not always the best thing, to be honest, with ASICs, because you could pull in a broken tool that's just recently been broken, and that could ruin your chip. So I think for the course and for experimental stuff, for trying things out, for submitting bug reports, for being on the bleeding edge is perfect. For doing tape outs, I think it makes more sense to be using an older version of the tools that has been proven to be fine, or to be like manually installing everything at a specific commit that you know is good. So for tiny tape out stuff, we'll still be recommending people submit their designs using the tools that are pinned in our GDS action. So that's just a caveat to be aware of. Okay, so, but yes, one thing I just wanted to come back to say on this was, one thing that I thought was really great was that, not this one, it was this one, the IHP 0P3 test chip, was that we only found out about that opportunity very late to do this another free open source tape out with IHP, and Uri was able to get the infrastructure adapted for that tiny chip, set it up, get the infrastructure working. We got 32, we filled 32 tiles from the community, and then did a tape out, I think all in about 2 weeks. So a really good testament to how good our infrastructure is. And I just want to say big shout out to all the team and all the contributors that have made that possible. We've come a long way. Maybe it's just worth, I've been writing some chip descriptions. So we've got our store. We've recently added Tiny Tapeout 6, by the way. If people are interested in Tiny Tapeout 6, we just added this. But the product details are, frankly, a little bit lacking at the moment. So I'm writing descriptions for all the chips. And as I have been going through them, I've just been really, again, like amazed at how cool this is and how far we've come from the very early scan chain days back in Tiny Tapeout 1 and 2. And it's really only would have happened thanks to all of you people in the community. So thanks for being involved, and thanks for tuning in and submitting your designs and doing what you all do. It's great. It's been a real lot of fun. Okay, moving on with the news then. Basilisk is silicon proven. So this is a pulp team project coming out of ETH Zurich and Luca Benini's lab. A big team effort. One of the things in their paper was that they said that, it's, what did they say? There was a little star and it says, all authors contributed equally to this research. Short paper, if you fancy reading it, just a couple pages. Top line is it's the biggest open source SoC at 34 square millimeters, taped out on IHP 130. If you've not followed this whole story, the first tape out they did of Basilisk was a disaster because there was a standard cell mess up. I can't remember the exact specifics. I think Thomas Benz spoke about this in Free Silicon Conference in 2024. So if you want the details on that, you can get that. But basically, one of the standard cells was the wrong one. So instead of being an AND gate, it was an OR gate or something like this. So it worked in simulation, but it didn't work once it had been taped out. That's been fixed now, and it's been taped out. It's quite an interesting chip. It's also got a DDR. So I didn't. What was it? What was the RAM? A DRAM controller. Sorry. 62 megabits per second, chip to chip, C2C link. It's quite impressive. It's all done with open source tools. It's good to know what the state of the art is, where we're at the moment. And the Pulp team is always doing fantastic work. So definitely check that out to find out more about where we are with these big SoCs, Linux capable 64-bit. So yeah, great job to the Pulp team. I'll just drop a link to that PDF in the comments here. And then just wrapping up on the events, we've got Latch Up videos. So Latch Up was in Santa Barbara beginning of May, just a month ago. If you've missed the videos, they're all up to date now. On the Fossey page, I just posted in the comments there. You've got this page, and then you've got this schedule with the links to the videos and the slides for all of these great talks. So definitely check them out. One of my favorites was the one on an overview of static timing analysis by Akash Levite. So check that out. Free Silicon Conference is coming up. That's going to be at IHP. I know that a lot of you watching are going to be there. I'm looking forward to seeing you. I'll be there. Going to hopefully do a little bit more filming in the clean room as well, which I'm looking forward to. Tickets are sold out, but don't worry, because we've got ORConf coming up in my home city of Valencia in September. The call for papers and registration details are already out. So I'm going to drop them down here as well. So hope to see you in Valencia for ORConf. Submit a talk, register. If you're representing a company with money, then please sponsor the event. I'll be helping to organize it and run it, and it'll be great to see some of you there. Okay, Rohan is saying the archive link is some other paper, not Basilisk. Oh, yeah. That's another paper that I was going to recommend you reading anyway, so it's good that I dropped that. But yeah, let me just find the Basilisk paper. There we go. There it is. Okay, any news? Did I forget any news? Anybody listening want to shout out? Want an event or a project or something else shouted out? Just let me know in the comments. Very happy to spread the word. Otherwise, we're going to move on to the main event. Bum, bum, bum. Topics. I put a Z80 in the background there, but I've just realized. Let me. Can I put myself on the side? You can kind of just see the chip there. 2 chips. Maybe I'll stop sharing my screen for a second. God damn it. How do I make myself small? Just wanted to show you that I actually do a bit of preparation for these streams, even if it's fairly low effort. So yes, Z80. Ray's been pretty busy. We did send out the Tiny Tape Out 7 in early of this year, January this year, but Ray's been pretty busy, and he has just got round to testing the Z80 with some test program. So my plan now is to see if we can reproduce that test. And then maybe write our own little bit of assembly. Let's see. It's been a long time since I've written any assembly. So I did a interview with him last year about the project. And if you're interested in checking that out, I'll drop that here. And yeah, Ray does a great job of preparing and documenting. So I had a great slide deck. And we talked about all the projects, what his aims and ambitions are. So I won't get too much into that. Let's take a look at the project here. 4 tiles. Let's check it out in the 3D viewer. Fairly high utilization. What have we got in the cells? Let's have a look how many flops there are. So the ones that I just disappeared are the flip-flops. And yeah, Ray was able to go from the news of April 15th to doing a tape out on Tiny Tape Out 7, which closed on the 1st of, I think it was the first design actually submitted. So he got that ready in about a week. It's pretty impressive. And then here we go with his documentation. Sam says he always finds it impressive how small the early processes are on a somewhat modern process. Yeah. So here's the docs, beginnings of the docs. So we can actually try this. Or maybe I'm going to just jump straight to the more advanced test. So in the Tiny Tape Out 7 Discord channel, Ray is asking for people to reproduce this test and let him know if it works. Let me just check if I've got that right. Test repo with instructions. So that's what we're going to do. See if we can get this working. Okay, so I'm pretty sure that he's using the RP2040 as the external ROM and RAM. So we've got the Tiny Tape Out 7 demo board. If you want to play along, there's a few in the shop. We've got the SDK already, and I've already got MP Remote. I think I'm on a fairly new version, so let me check that. I think actually, okay, I've updated my Ubuntu recently to 24, and one thing I've found out is that if you do something like, it's going to complain and tell me I'm not allowed to install this, and I have to install it another way. So I think the idea is it's trying to push you into using virtual environments. So 1.25.0 should probably be so new that it's broken. Let's see. Okay. And then we need to copy over. So let's see if this is just going to work. I've got my TTO7 board plugged in already over here. Doesn't look like it's doing anything. Oh, probably because I have am I running the Commander? Yes. Let's try that again. Nope. We just plug and unplug this. Okay. Let's try again. Oh, there we go. I'm not sure what that resets for. Do it anyway. Okay, and then we connect to it. It's funny, I thought if there was only one device connected, it would just do it for me. Oh, yeah, no, it does. Oh no, that's ACM0. Maybe that's why it doesn't work. I've got another device connected that isn't the right one. Okay. Okay, let's reboot this. Demo.hello. Oh, it's doing something. Let me just maximize this for a minute. Hello, world. Z80. Cool. Dun, 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 dun. So I will officially report this is working now. And probably I need to disconnect from here though to do that. Cool. Does it update straight away on Silicon Proven projects? Feedback. Yes. So good. And is anyone watching who's got a Tiny Teapot 7 board handy? You want to check this as well? Let's try this other one as well. Emulates ROM, flashes LED with text. Okay, it's definitely doing some flashing here. Just realized I'm still in solo layout, so you missed me submitting my feedback. I was just impressed that I submitted the feedback through the commander and then immediately it's on the website. And then the last one was prog RAM. Print sim in the MP remote console. I mean, I don't know what it's supposed to do, but it's doing something. So, who fancies helping me modify one of these programs? Let's try this super simple. Well, let's actually, let me first see if I can assemble this and get a COM and then upload it and see what happens. So this was the macro cross assembler. Okay, I'm going to need to install this somehow, maybe. Source code builds easily for Mac and Linux. Okay. Oh, I've got a makefile. That's cool. Oops. Yeah. Oh, no yak. Oops. You can tell how this is a new install of Ubuntu. What else is going to be missing? Bison. Dang. Do we have a README? Or is that just for docs? That's not looking too great. Anyone aware of a Z80 compiler that I could try? This is, I think, beyond my ability to debug on a stream. Zmac.y. Is there an online Z80 compiler? Ooh. It's emulator. It says it's assembled it with 6 errors, but it's saying that some of these errors look important because it's saying error parsing line message 1, and I think that that is fairly important. Otherwise, it's not going to work, is it? Let's try again. Error on line 41. Unfortunately, no line numbers. It's not exactly what I... No, they are there, yeah. But it's all comments, though, isn't it? Jump to 0. Error on line 41. Yes, Sam's asking for the test project that is here. Ray's telling me that Zazam works. Okay, that's saying 59 lines, 2 passes, no errors, and I can download a list or a ROM. To actually know which one of those I want. I think the files that Ray's given here are .coms, whatever .com is. Just binary, maybe. Let's take a look at this ROM. 86 bytes. Oh, look at that. It's looking good. Same file. So let's let's just go through the, well, maybe let's make one change. Let's try and change, instead of hello world, we'll say hello stream. Will it be able to do that though? How does it actually, I don't actually understand how this works. How's it interpreting the string here into what's going to get put out on the 7 segment? Let me run this hello again. Let me just check it. Oh, that's running really fast. Okay, now it's counting up. And then it does little dots, and then it says Z80. Hello world. I'm interested to know how that is happening. What's going on in the background? Let's just try changing the thing and seeing what happens. So, hello, Matt. So I'll come back over here. Updated 1753, binary, Z80, assemble. Just move that file and then download the new one. Okay, so there's got 2 different ROMs there now. So let's quit here. And then I needed to, I guess, copy back hello.com to somewhere new. So we've got the hello.com there. So I'm going to do downloads hello.rom to mat.com. So now I've got the mat.com in there. And then I'll need to import oops, memory allocation failed. And then let's try. So now we should be able to do, oops, that's the wrong one, but still. Okay. It's flashing very, very fast. Let's try mat.com. Okay, it's doing something, but it's too fast for me to read. But it's actually printing something out on the screen. I hadn't realized that. So Z80, I guess. Yep. Oh, look at that. Hello, Matt. Yahoo. Managed to write a Z80. Well, I didn't write it, did I? Managed to modify a Z80 program, assemble it, and run it on an open source Z80. Good stuff. Good job, Ray, for your documentation. I guess the only thing I would say is add some links in here to where people can find online compilers. Am I getting my language wrong? Is it assemblers that I should be saying? Really, by the time I guess my first programming language was probably BBC Basic, and then I just went. I think I did a tiny bit of assembly, and I just went straight to C. So this is the one that works the best for me. Okay, well, that's great. Got there in the end. Z80, hello Matt, Z80. So, and if anyone is out there who wants to play with the Z80, let me just move to my outro screen. There we go. If you're a Z80 fan or a retro computing fan, then check out some of the Tiny Tape Out projects. I've got quite a few retro things on there. Obviously, the Z80 we've just been having a look at today with Ray's open source Z80 design. There's a few of those left in the shop if you want to get your hands on one of those. Thanks everybody for tuning in. Subscribe, like, all that good stuff, and I hope to see some of your designs on our next tape out. So take care, have a good week, and I'll see you next time. Bye-bye.